Okay, so our first problem is a simplifying problem. We have a 4 out front, so we want to make sure not to lose the 4. And it's a cube root. So I'm going to take 40 and prime factor 40. It's divisible by 2. It gives me 20, which is divisible by 2. Gives me 10, divisible by 2. Gives me 5. I can see that I have 3 factors of 2, so that's going to go out front and leave me with a 5 inside my radical. So my 4 will still be out front, and I will have 2 cube roots of 5. And then for my variable parts, remember for the variables, I always want to think about it as exponent divided by an index. So when I look at x to the 4th, I can't divide 4 by 3, but I can break my x to the 4th into x cubed and x. And x cubed I can divide by 3 would give me 1x out front and leave me with an x inside of my cube root. For the y term, I just have one y, which isn't divisible by 3, and I cannot break it apart, so that will stay inside the cube root. For the z to the 11th, I would want to break that into the largest possible exponent value that I can divide by 3, which the next largest value after 11 that's divisible by 3 would be 9. So I would break this into z to the 9th, which then would leave me with z squared. So z to the 9th, if I divide that by my index of 3, would give me z cubed out front, and it would leave me with z squared inside my radical. So finishing this up, the 4 times 2 out front gives me 8 x z cubed, and then I have a cube root of 5x y z squared. That's my final answer. Make sure on your test that you don't lose the cube root. Okay, right here, you don't want to lose that part. Okay, instead of having it a square root, make sure you have that little 3 there. Okay. Okay, so the next one's simplifying as well. So for the 50, if I prime factor 50, oops. So if I take 50 and prime factor it, 5 goes into 50, leaves me with 10. 2 goes into 10, leaves me with 5. So it's a square root, so I'm looking for a set of 2. Notice that these are out of order, but I have a set of 2 5s there. So the 5 will go out front, and it'll leave me with a 2 inside my radical. So I will have 5 square roots of 2. For my variables, I'll have the exponent divided by index again. So for the x to the 5th, remember I want to break that apart. So I'll have x to the 4th and x, because 4 I can divide by my index of 2, but I can't divide 5. So x to the 4th divided by 2 would give me x squared, and it would leave me with 1x inside my radical. The y cubed I can break into y squared and y, and the y squared I can bring out front would give me 1y, because 2 divided by an index of 2 would leave me with 1, and the 1y I would have inside the radical. And z to the 12th is evenly divisible by 2, so I can do that entire radical leaving me with z to the 6 out front. So writing it all together, I would have 5x squared y z to the 6 square roots of 2x y. It's the final answer. Okay, the next one is multiplication. So remember, any terms that are outside can be multiplied with other terms that are outside, and any terms that are inside radicals can be multiplied with other terms that are inside radicals. So when I multiply here, the 4 times the 5 would give me 20, and the root 3 times the square root of 8 would give me the square root of 24. And then once I've multiplied, I want to then simplify what I have left inside the radical. So I want to take the 24 and prime factor it. And when I prime factor it, I see that 24 gives me 2 root 6. So I can rewrite this as 20 times 2 square roots of 6, or 20 times 2, which gives me 40 square roots of 6 for final answer. So you just want to be really careful that when you multiply, that you also then make sure to simplify whatever you've multiplied together to make sure that it's simplified all the way and that you've multiplied everything back together. Anything outside the radicals can be multiplied together once you've simplified what you have left. Okay, so on this one, we are going to distribute the 5 radical 3 into the parentheses. So when I distribute 5 radical 3 to the 7, 5 and 7 are both outside the radicals. So they're going to get multiplied together to become 35. And the radical 3 will just stay radical 3. When I multiply the 5, and the negative 6 together, I will get negative 30. And then the 3 and the 7 will give me 21. So again, anything outside radicals will get multiplied together when I do this distributing, and anything inside radicals can get multiplied together. I would then look and see if I can simplify anything. On this problem, nothing can be simplified, but if I could simplify it, I would, or if I had any like radicals, I would add them together. On 5, this one we talked about last class. Be very careful when you get to a problem like this that you don't make this silly mistake of like trying to distribute that exponent in. You can't distribute that exponent in. 5 minus the square root of 5 squared means I have 15 minus the square root of 5 times 15 minus the square root of 5. And then I need to multiply that out, meaning I'll take 15 and distribute that to both of the terms in the second parentheses. So 15 times 15 gives me 225. 15 times negative root 5 gives me negative 15 square roots of 5. And then I will take the negative root 5 and distribute that, which will give me negative 15 square roots of 5 plus root 5 times root 5. It's going to give me positive the square root of 25. And then there's a few things we can do here. The square root of 25 just becomes plus 5 because 25 is a perfect square. And then 225 and 5 is just going to give me 230. And then negative 15 root 5 and negative 15 root 5, those are like radicals, so it's going to give me negative 30 square roots of 5. I can just add the coefficients together, negative 15 and negative 15. And there's my answer. Okay, so rationalizing the denominator. First thing you want to do is simplify anything that you can. So you can simplify numbers that are outside radicals with other numbers that are outside radicals, numbers that are inside radicals with other numbers that are inside radicals. So one thing I see here is the 4 and the 2 can be simplified. 4 over 2 just gives me 2 over 1, radical 2. And then to rationalize the denominator, you want to multiply both the numerator and the denominator by the radical that's in the denominator. So that's going to give me 2 radical 2 over root 2 times root 2 is going to give me the square root of 4. Well, the square root of 4 is 2. And then in this case, 2 over 2 is just 1. So this would equal just the square root of 2. Before you rationalize the denominator, this one has root 2, which is already simplified, but you would also make sure to simplify whatever radical you had there before beginning. So like if you had the square root of 8, you would prime factor that and simplify the radical before deciding what you're going to multiply the numerator and denominator by. Okay, an addition problem. So I have 4, and then the square root is 75. So 75, if I were to prime factor 75, would give me 5 radical 3. So then I'm going to end up with 4 times 5 radical 3. Let me rewrite that. That's horrible. So I'm going to get 4 times 5 rad 3 minus 6. And notice I'm being very careful to write the coefficients that were already there. So I have 6 radical 3 plus 4. I can't simplify rad 5 any further. Minus 12. Radical 12. Radical 12 would simplify to 2 rad 3. So as I go through and look for like radicals, I see a radical 3, and radical 3. This is a rad 5, and I won't be able to add that with my radical 3's. Simplifying what I have here, 4 times 5 gives me 20 radical 3 minus 6 radical 3 plus 4 radical 5 minus 2 radical 3. So then adding up my radical 3's, I have 20 minus 6 gives me 14, minus 2 gives me 12. So all I'm doing there is adding up my coefficients. The radical does not change. And then I still have the 4 radical 5. In another addition problem, I would prime factor all of these. I'm not going to show you all of that work here. The 20, if you were to prime factor it, you would see would become 2 rad 5. And then I would have minus 6 times, the 6 was already there. That's a coefficient that was already there. The 125 would become 5 radical 5 if I prime factored it, plus 3 times 2 rad 2. So again, the like radicals that I have are right here. This radical 2 is not going to be able to be combined with the other radicals, the rad 5s that I have at the beginning of the problem. Simplifying what I have 2 rad 5 minus 30 rad 5 plus 6 rad 2. And then adding my coefficients gives me negative 28 rad 5 plus 6 radical 2. Okay, that's it. Good luck on your test.